magnetic field of the Earth. The Earth itself is a huge magnet. It acts as a short bar magnet inside the Earth. This apparent magnet is inclined at a small angle with the axis of rotation. Let me show you. This is the structure of the Earth, and this is an axis of rotation. So this is apparent magnet is acting at a small angle of the axis of rotation. So in such a way that the southern pole of the magnet inside the Earth is rotating in the northern hemisphere, while the northern pole of the magnet pointing in the northern hemisphere. As it is shown in the diagram. You see the bar magnet is shown south pole and the north pole. What is the origin of the Earth's magnetic field? The origin of the Earth's magnetic field is not well understood, although there are several theories tried to explain this. The most acceptable theory is the dynamo effect. As we know that the Earth is composed by three components, that is the mantle, crust, and the core. In the case of the core, there are two types, that is the inner core and the outer core. The inner core is the solid in nature, while the outer core is the liquid in nature. So once the Earth is rotating its own axis, once the Earth is rotating its own axis, creating the current, means rotation per unit time is a current. This current creating the magnetic field. In every current there is a magnet, so creating the magnetic field in such that although there are other sources of the magnetic field, this includes magnetized rocks on the Earth's crust, electric currents in the ionosphere and magnetosphere, as well as the currents induced in different parts of the Earth, that is the crust, mantle, and oceans by varying magnetic fields. Structure of the Earth's magnetic field. The Earth has two poles. The Earth has two poles. This is the geographic pole and the magnetic pole. The geographic pole is described by the axis of rotation, while the magnetic pole is described by the magnetic field. The magnetic south pole pointing in the northern hemisphere, while the magnetic north pole is pointing in the northern hemisphere. Also here it is a compass which shows the direction of the magnetic field. Variation of the Earth's magnetic field. There are two types of variation of the magnetic field. We have the spatial or global variation and the temporal variation. For the case of spatial variation or global variation, this is the variation from place to place. Generally, the magnetic field of the Earth is about 4 times 10 power negative 5 Tesla. At about 32,000 kilometers above the Earth's surface, the magnetic field of the Earth falls to about 10 power negative 60 Tesla. Also, at a distance above or greater than 32,000 kilometers, this field pattern falls to approximately to zero. The distance gets severely distorted by solar winds. Also, we have temporal variation. This is the variation of the magnetic field from place from time to time. In this case, we have short-term variation and the long-term variation. For example, to about 240 years, the from 1580 to 1820, the magnetic declination at London has changed by 35 degrees. Causes of the short-term variation are external factors such as the rotational motion of the moon, earth, together with the currents in the magnetosphere and the ionosphere. Here we have the table for the variation of the magnetic field from time to time. Long-term variation. The long-term variation are on geological time. It is about 10 power 5 to 10 power 6 years. In this case, the magnetic field reverses its magnitude and direction in every million years. The long-term variation is caused by the dynamics of the Earth's interior. Components or elements of the Earth's magnetic field. There are three components of the Earth's magnetic field. That is angle of declination, theta, angle of declination. This is the small angle between the magnetic meridian and geographic meridian. Angle made between the geographical North Pole and the magnetic South Pole. This is the angle between the angle of declination, theta. Importance of the angle of declination. This is the angle of declination is important in sea and air navigation. Also, we have the magnetic inclination or magnetic dip. This is the angle made between the total magnetic field, the resultant magnetic field, to the horizontal line of the magnetic meridian. The horizontal line of the magnetic meridian and the resultant magnetic field. The angle between that is the magnetic inclination or angle of dip. This angle of dip its symbol is sigma symbol. The sigma symbol. So angle of dip it varies from place to place. For example, at the poles, the angle of dip is 90, while at the equator, the angle of dip is 0. In this case, the magnetic compass becomes horizontal, while at the poles, the magnetic compass becomes vertical. Also, we have the horizontal component of the Earth's magnetic field. In this case, this is the total magnetic field along the horizontal direction, the magnetic meridian. Is the total magnetic field, total component of the magnetic field along the horizontal direction of the magnetic meridian. So what is the importance of the magnetic horizontal component of the Earth's magnetic field? The horizontal component of the Earth's magnetic field is used in navigation. Also, it is used in determining the strength of the magnetic force on a compass needle. Also, it helps to calculate magnetic quantities in experiments. Also, it is used in determination of declination and the dip. of deep by knowing the value of H. Also, it is important in geophysics and the earth studies. Generally, let me see the application of Earth's magnetic field. The Earth's magnetic field is used in map readers by map readers for finding location of the different places. It gives information for searching of minerals. Reversals of the Earth magnetic field reversals of the Earth's magnetic field provide the basis for dating rocks and sediments. And also map readers with a magnetic compass can locate the direction of the magnetic north using the compass. Also, it protects the Earth from cosmic radiation, potential damaging high energy particles from the sun. Okay. Follow the exercise below. Thank you for watching. You're welcome again. Don't forget to subscribe. Thank you. Bye bye.